Something new for teardown tonight. A Coherent laser system, Novus 2000. This system was used for eye surgery and it's now on its way to the scrapyard because there are some parts missing and it has a lot of error codes. Nobody knows what they mean because there is no maintenance manual around. It's difficult to get one. Compared with today's semiconductor laser systems, this is a very inefficient device. Through this plug, 20 kilowatts of electric power go into that machine, and through this fiber optic cable 2.5 watt of all that power come out again, and the rest is converted into heat. So I just plugged it in and it's time for the last power up. Let's see what's happening. Display test first. Then a countdown, maybe to heat up some stuff inside, self-tests, etc. Interestingly, the laser emission sign comes up, so maybe we can see if there is really something firing up. And now error codes: error 1, error 2, 3, 4, error this and that, error 3, which is possibly not a very grave error. Okay, power off. Now the first problem here is we have absolutely no screws. There are only some tiny little holes here and here up the panel. And thankfully someone else on YouTube has made a video and showed me the trick. You have to push something in and then lift. So the whole trick is to lift this rod here, which unlocks these two bolts. And here is the laser tube. It's a liquid-cooled Argon laser, 2.5 watt output power and many kilowatts of input power. We have a big fan down here with a water cooler radiator underneath that cover here. On the other side we have a water reservoir, cooling pump, water pump. We have also water cooling for the electronic box here, which is the laser power supply. And here are a bunch of fuses in an interesting drawer-like compartment. Power input goes to a big switch here, which is now off, but I have already unplugged it. Big power resistors, some probably ballast coils for the laser. This one is the a board that regulates the fan speed according to the temperature, which is measured somewhere down here, depending on the water temperature. Okay, that's about it. Let's open some covers. Okay, aluminium cover is off. We can see inside the power supply, water cooling. The water cooling line makes a loop here with a copper tube. We have a bunch of, what's that, diodes, triacs, I don't know. Maybe you can find it out. We have some big transistors, IGBTs I would say. We have some current sensing coils here. All the current goes to these 2, 3, 4 coils to this central point, or comes from that central point. We have a lot of big capacitors, each one equipped with a bleeding resistor here. This is a nice touch because these capacitors store electric energy for a long time, and these resistors here are simply to discharge them within a reasonable time. Inside here is distilled water. That's a problem when you store these lasers in a scrapyard outside. It can freeze and damage the cooling system. So let's see if we can remove the top cover. It seems that opening the front panel is quite easy. You only have to push here. Okay, I have already pushed that. It only works one time. And then on this side. Okay, it's also already open. And then we flip that over. Okay. What do we have? Some flex print. Where are they going? I don't know. Do we have some membrane keys here? No. Okay, we will see later. There's a big black box with a laser symbol on it. Very interesting. And that's the output fiber here. As you remember, the laser is down here. Shoots into this box, and somehow the light gets out through the fiber. Let's see into the box. So the first thing I want to salvage is that mini laser tube. It has its own power supply down here, so it should be easy to make that work again. Let's see. Okay, maybe it's easier than I thought. I just can unhook these springs here and remove the tube. That's the output window. So where are the cables going? They are going underneath. I never had such a tiny little helium neon laser. It's very cute. Oops. That's the aiming laser for the surgeon, so with the red light he can aim his beam and then press the foot pedal to do whatever he has to do. Okay. A lot lot of cables and cable ties. Fortunately, everything is plugged. Okay, that's the power supply for the helium neon laser. It says input 12 volt, output 1250 volt at 4 milliamps. Okay, I have it now here on my workbench, and it turned out that the red wire is positive 12 volt. The black wire is negative 12, and the yellow wire is a TTL logic input that must be tied to ground to make the laser start up. Let's see how this looks like. And it's already here. We also have a little bit of light on the other side. Maybe we can make a double-sided laser sword out of them. And we have a pretty bright laser dot here. Well, that's it from that little thing. I'd really like to light up the big tube, laser tube here too, but it makes not much sense because first of all it's broken and it's only made to make short pulses of a couple of milliseconds. It's not made to have a continuous beam. So, well, but it will be nice to take it apart. But first I have to drain the water. There is the drain for the rest of the system. I have already drained the reservoir. Let's hope this pan here is big enough to hold all the water. Okay, drain plug is a little bit inaccessible. Maybe I have to flip over the entire machine to get there, but I found another way to drain the water. Okay, I think at least the laser tube is empty now. Now I have to look for a rag to wipe this mess here dry again. It seems the laser tube is only mounted with 1, 2, 3, 4 little screws. Let's see if that's right. It seems that the laser tube is made easy accessible to make it easy to change. Maybe you have to change it every few hours. I don't know. I just think my screwdriver is too short. Okay, let's have a look at the beast. 2 white wires here are most likely the filament wires, the heater of this of the cathode, because the anode is definitively, thank you for the marking, on this side. That's the high voltage wire. Quite a big one, high voltage, high power. As I said before, you need about 20-30 kilowatt, not gigawatts but kilowatts, to make 2 watts of laser optic energy. There's some kind of bellows that compensates for thermal expansion, and here in the black tube is a reservoir of gas. It's protected here by this, okay, it's just a metal tube. So I think this is full with argon gas. There is a model number and a serial number. I hope you can read that if you're interested. There are even more numbers here, maybe separate numbers for the laser tube and the reservoir. Then we have a big coil here, copper windings around the tube. I think that is to make the beam diameter even a little bit smaller. I don't know, I'm not a specialist of this kind of lasers. And here is the bad side, the dangerous side, the laser window. It looks like it's working because that's about the color you get from this laser, a blue-green color like the mirror effect here. Okay, let's see what we can do with that a little bit later. So this is how to remove that front panel, or better how not to remove it, because I have the wrong screwdriver. Okay, I messed up the screw. Let's do it on this side. There's always one screw that goes hard or not at all, and it's always one of that you didn't expect. Okay, so let's be a little bit brutal here. I certainly don't need the cables, but I will keep these switches. They are nice and expensive. Okay, so that's how it goes. Nice EAO switch, made in Switzerland. That's the emergency button here. Key switch. It's a little bit loose. Okay, that's all right. By the way, isn't that logo reminding you on Star Wars somehow? Maybe they were inspired by the Death Star. Okay, let's connect the electronic cooling. Disconnect better. Okay, let's walk around and see what we have. We have a nice stable trolley made of solid aluminium. It runs quite well. Could be equipped with an IBM fan for a jet propelled car. Then we have, of course, a laser tube, some hoses, a pump and a reservoir. And here we have, I guess, it's a water level switch. I think there is some, well, maybe we have to watch it like this. There is a floating device here with a magnet, and I think that's a reed switch here. And when the water level drops, this switch gets open or closed and we get an alarm on the display. An error code that no one understands. Okay, what do we have else? I have here something that looks like a electroluminescent inverter. Maybe these cables go to a backlight panel of some sort. I just don't see where exactly that should be. Maybe we find it out. Then we have a very cool cooler. Nice. Big 220 volts with an electronic regulator and a temperature sensor, which can be used for all kind of stuff. Then we have transformers. They are not that interesting. We have big switches, mains input. We have a small power supply. How much does it say what? No, I think could be 12 volt, 5 volt for the logic. Then we have logic boards, more transformers. We have also a capacitor. I hope this one is not for the pump. No, I think that goes. No, that goes in another direction. That goes into this coil. Some sort of resonant transformer thing. And the water-cooled electronics and a lot of quite thick aluminium. That's where the laser tube was mounted. Wow. Everything heavy. Okay. And I think with the laser tube I make another video, and maybe we have some more parts to play with. Thanks for watching.